Welcome back, Bridge 1 students. After the silent video I made for you, where we created a triangle incenter by constructing the angle bisectors of a given triangle, that's this image right here, you'll recall. I wanted to take a look at the applications of angle bisectors and have you used deductive reasoning to come to quantitative conclusions about problems with triangles and angle bisectors. But first, I want to just point a couple things out. We have, this is a reconstruction of what I did. It's the same drawing I did in the other video, but I've marked out some facts here. If we have three angle bisectors in a triangle, and they meet at the incenter. Here's again the incenter is point D here. That's the spot where the three angle bisectors cross. Okay. We have an incenter, and we might want to also notice some things about these angle bisectors. First of all, by definition, you'll see that the three angle bisectors, they bisect the angles, which means that, for instance, this angle here, I'll try to show it in this blue highlighter since I have it in a blue color. This angle here, oops, and this angle here. In other words, angle BAD, bad, angle bad, and angle DAC, angle DAC, are congruent, okay, because that's an angle bisector. I'm going to write that down. Angle bad, BAD, is congruent to angle DAC. Okay. You also might want to notice some properties here. We're going to look at a theorem related to this in a minute, but just looking at this, you can see that if there's a point on the angle bisector, for instance, I'll go back to this red color, this point here, this point here, this point here. Yeah. Then the segments, the perpendiculars connecting the sides of the angle are going to be congruent as well. So for instance, we'll use this orange color here. Segment EF here is going to be congruent to segment FG. You can kind of see that, right? Segment HI will be congruent to segment IJ. And I've marked it out there with those tick marks. Same thing here. It's kind of a very elegant, beautiful, symmetric way of looking at things. Also notice these perpendiculars. I think that's important to sort of see the perpendiculars here. Yeah. All right, so let's just mark that down too. Get a sense for that. You know, for instance, if we just look at this angle A, then we can see that line AD, or segment, it's a line, actually ray, really, I guess, the way I've drawn it, AD bisects angle A. And we know this already about the angles, but we also know that segment, like I said, segment, say, EF is congruent to segment FG. It's important to name things carefully in geometry. Segment HI is congruent to segment HJ, etc. Okay, with that said, I think that we're ready to go to some new theorems. We have what's called the angle bisector theorem that says that if a point is on the bisector of an angle, then it's equidistant from the sides of an angle. which means, for instance, that like this point F right here has to be, since it's on the bisector, it has to be equidistant from the sides, and I've shown that here. The converse is you just turn it around. If a point is in the interior of an angle and it happens to be equidistant from the sides, notice that point I here, for instance, it's marked as equidistant here and here from the sides, then it has to be on the bisector. That's the converse. And then I've described the incenter already. It says that the angle bisectors of a triangle intersect at a point that's equidistant from the sides of the triangles. This point is called the incenter. Okay, beautiful construction. The problems in this lesson are going to look kind of like this. Find the measure of angle ABC. That's the big one here. Angle ABC. This whole large angle here, yeah? Given that the measure of angle DBC here is 28 degrees. DBC. And really, the key to this is that we have this situation. It says here, we're given that this is a distance of 32. It doesn't even say 32 what, but that this distance is 32 on the perpendicular between D and C is 32 units. The perpendicular between D and A is 32 units. And then we know that here, if a point on the interior of an angle, I'm going to kind of make this bigger, I think. Yeah. If a point is on the interior of an angle is equidistant from the sides of an angle, and that's true about point D, then it's on the bisector of the angle, which means that this angle here, BAD, angle bad, we're back to angle bad, it's got to be also 28 degrees, which means in turn that this whole angle, we looked at it earlier, this whole angle here, ABC, this whole one is 28 plus 28. And so we can say that the measure of angle, oh, that looks terrible, angle, I'm gonna get this right here, guys, angle, good enough, ABC equals 28 plus 28, which is 56 degrees. Have fun with this lesson.